Okay, here is a question. A small sphere having mass 1.0 into 10 to the power minus 3 gram carries a charge of 2.0 into 10 to the power minus 8 coulomb. It hangs from a silk thread which makes an angle of 30° with a large plane conducting sheet. Calculate the surface charge density of the sheet. So first of all, what is given in the question? We have the sphere of mass m. Mass m equals to 1.0 into 10 to the power minus 6 kg. And charge of that sphere is Q equals 2.0 into 10 to the power minus 8 coulomb. Okay, first of all, it hangs from a thread. It hangs from a silk thread from point 2 in front of a plane conducting sheet. So what we have to find out? Surface charge density of the sheet. So let sigma be the surface charge density of conducting sheet. Let sigma is surface charge density of sheet. So here the charge density is given, and we know that the electric field due to this plane conducting sheet is E equals to sigma by epsilon naught. If we are supposing the sheet is positively charged, then electric field is outward of this sheet, normally outward. So due to this electric field, the sphere which is hanged from silk thread will get force. Then force experienced by sphere is F equals to QE. This is the electric force experienced by the sphere which is hanged from silk thread. Due to this force, this sphere gets displaced to the new position. Now, according to question, the string makes an angle of 30° to its initial position. Theta equals to 30°. Now, one force that is experienced by this sphere is that one force is horizontally away force, that is electric force Fe equals to QE. And other forces acting on that sphere are, one is gravitational force mg, vertically downward, and another force is tension T towards the point of suspension. And here, since the sphere is at equilibrium or stationary condition finally, so the sum of all forces must be equal to 0 that are acting on the balls. For this, let's resolve this tension T into two perpendicular components. One is T cos theta, perpendicular to the electrostatic force T cos theta. Theta is angle between this perpendicular line and tension T. And other one is T sin theta, which is opposite of electrostatic force. And for net force to be 0, we must have T sin theta equals to Fe. If these two forces are equal, and since they have opposite direction, the resultant of T sin theta and Fe will be equal to 0. Similarly, if T cos theta equals to mg, then the resultant of T cos theta and mg also 0. So if this condition happens, then the net force acting on that sphere will be equal to 0. Now let's solve this equation. Dividing equation 1 by 2. Upon dividing, we get tan theta equals to Fe by mg. Okay, from this equation we can write Fe equals to mg tan theta. And since Fe equals to QE equals to its mg sin theta. And since E, electric field intensity due to this plane conducting sheet, E equals to sigma by epsilon naught. Therefore, Q sigma by epsilon naught equals to mg tan theta. mg tan theta. So sigma, the surface charge density sigma equals to epsilon naught mg tan theta by q. Let's write the values. Epsilon naught 8.854 into 10 to the power minus 12. The mass is given in the question. It's 1.0 into 10 to the power minus 6 g. Let's use the value 10, and tan theta is 1030, and the charge is 2.0 into 10 to the power minus 8 coulomb. So upon calculation, we get the answer 2.52 into 10 to the power minus 9, and the unit of surface charge density is coulomb per meter square. So this is the answer.